The Webb scope is so far out that it's picking up light that's been traveling for over 13 billion years. Because the universe keeps getting bigger, the light stretches as it travels from seriously distant spots. We're basically looking back in time, almost to the Big Bang. The universe is huge, but get this, it all started from a tiny thing called a singularity. That's how we think the Big Bang happened. Anyway, the James Webb Space Telescope, JWST, has turned up some crazy mysteries about how the universe started and grew, leaving everyone scratching their heads. Brian Cox, a cool physicist, even said the JWST's finds could totally change how we see the whole universe. Want to hear about this crazy discoveries that will blow your mind? The James Webb Space Telescope, named after a big name at NASA, is a total game-changer for space research. It's a huge step up from the old Hubble Space Telescope. NASA, Europe, and Canada teamed up to make it. The JWST is way better than Hubble because it uses super advanced stuff to see the universe in crazy detail. Unlike Hubble, the JWST takes super clear pictures of faraway stuff in space because it mostly uses infrared. This lets them look through cosmic dust and see things we couldn't before. Its massive 6.5-meter mirror made of 18 hexagonal pieces dwarfs Hubble's mirror. It hangs out about 1.5 million kilometers from Earth at the L2 Lagrange point, circling the Sun with us, so it always has a steady view. Looking back into the universe is like time travel. The JWST uses infrared to check out stars, planets, and stuff that happened billions of years ago. Light from these objects stretches out as it travels because the universe is getting bigger. This stretches out from the visible spectrum to the infrared. Luckily, the JWST can spot the infrared light from super far objects, which lets scientists learn about how stars came to be, how galaxies change, and what exoplanet atmospheres are like. One of its latest finds: a crazy amount of galaxies way out at the edge of what we can see. This makes us rethink how we even came up with the theory of how things came to be. To get a better sense of this, let's take a quick trip through the history of space stuff. The early Greeks and Chinese were the first to figure out how planets moved by watching them. Then, Newton's laws in the 1600s gave us a way to understand space travel. Eventually, Edwin Hubble, a top astronomer, he showed that faraway nebulas were actually separate galaxies way beyond ours, changing how we saw the size of the universe. He came up with Hubble's law, which says galaxies that are farther away are moving faster, meaning the universe is expanding. After World War II, the space race started, with the Soviet Union launching Sputnik in 1957, the first satellite ever. Then, Yuri Gagarin orbited the Earth in 1961, and Apollo 11 landed on the Moon in 1969, major wins. Fast forward to 1990, when the Hubble Space Telescope gave us amazing views of space. So, from ancient stargazing to the James Webb Space Telescope, we keep getting closer and closer to understanding the universe. It showed us how incredibly huge space is and changed our basic ideas about astronomy. Take the Hubble Space Telescope, HST. It snapped the famous Pillars of Creation photo in the Eagle Nebula, showing a star nursery inside big columns of gas and dust. Another big deal was the Hubble Deep Field, which captured tons of galaxies in what seemed like an empty spot in space. The HST even checked out exoplanet atmospheres and found stuff like water and organic molecules, hinting at possible habitable zones beyond our solar system. It also watched SN 1987A, the closest supernova we've seen, giving us insight into how big stars live and die. These wins made Hubble a cornerstone of modern studying space. It wowed the world with discovery. The James Webb Space Telescope was launched to pick up where Hubble left off and build on what we know now. Today, we got a theory that says about 13.8 billion years ago, the universe started as a super hot, tiny point that quickly got bigger, creating all the stuff, energy, and forces we know. As the universe expanded, it cooled down and formed atoms, stars, galaxies, and everything else we see now. The Big Bang theory also explains the cosmic microwave background radiation, the amount of light and the way things are arranged. Even though it's the main theory, the Big Bang theory had its doubters at first. Some people suggested other ideas, like the steady-state theory, which said the universe didn't have a starting point. But, over time, we found proof that supported the Big Bang, like the cosmic microwave background radiation in 1965. Space missions like COBE and WMAP kept backing it up with precise measurements of the cosmic microwave background radiation, which matched the theory perfectly. Now, here comes the James Webb Space Telescope, with its infrared gear that can see through cosmic dust. It captures the oldest light in the universe and finds stuff that formed right after the Big Bang. Because it uses infrared, it can peek into star-forming areas and see how stars are made, where optical telescopes can't. Infrared light can cut through space dust, which Hubble couldn't do. The JWST can also see cooler objects that mostly emit infrared light, which is great for studying exoplanets, brown dwarfs, and distant galaxies. When stuff in space moves away, the light it gives off stretches out, causing redshift. The JWST can spot this infrared light, grab light from the early universe, and tell us how it formed and changed. Energy from stuff like black hole collisions or new stars being born shines bright in infrared, too, which the JWST can see when old scopes couldn't. The JWST works with telescopes like Hubble, but it's more sensitive. The JWST can see further and deeper into space, revealing hidden stuff and giving us the big picture of how the universe has changed. Recently, it showed us something so wild that it might make us rethink our whole model of the universe. We found huge groups of galaxies way out at the edge of the observable universe. These old galaxies popped up just a few 100 million years after the Big Bang, during something called the cosmic dawn. The weird thing is, we don't know how those structures got so big so soon. This can make us rethink how galaxies were formed and how they changed in the early universe. Checking early galaxies is key to understanding where we came from. The JWST can teach us how galaxies, stars, and planets came to be and grew over billions of years. Plus, it helps us answer big questions about the universe like what it's made of, how it's put together, and what forces shape it. While the Hubble Space Telescope was cool for its time, it had its limits when it came to seeing the early universe. It couldn't see through space dust and spot the infrared light from old galaxies. Old telescopes used visible and ultraviolet light, so they couldn't see the early universe, where stardust and gas block those light wavelengths. The James Webb Space Telescope is a huge leap in seeing galaxies from the start of the universe. The JWST can spot those objects that formed a few 100 million years after the Big Bang. The JWST has seen a bunch of old galaxies, giving us a clearer picture of how the universe started out. The JWST has already stirred up trouble. The data is getting some cosmologists to question the principles of how we understand cosmic evolution and structure. JWST's new eye has given a look at a larger amount of galaxies in the early universe. Some of the galaxies appear more developed than expected. Does the existence of the cosmic web cause challenge and pose question to previous ideas? These things lead to more fascinating questions. The JWST needs exploration to create a comprehensive exploration. These initial investigations can provide exciting information to the universe. Sometimes they reveal variations. Here is what happens for accuracy. Spectroscopy is the tool to use for the unraveling of history on cosmic objects. It is an analysis and examination of the light source. The composition of light can reveal the elements of chemical compounds, density, source bodies, and the movement. JWST has discovered the variation in light, and this challenges chemical and compound of the early universe. The telescope is redefining how we know the universe. It shines a new light on the hidden areas. It has an excellent ability to study the exoplanets for the understanding of habitable sources. There is water, oxygen, compounds that helps to determine if life can actually be found. The examination does include the ability to transform the understanding from dense gas and areas where stars are created. The ability to see those glimmers shows that star and system development in the universe. Take the Hubble Space Telescope. It snapped the pillars of creation in the Eagle Nebula, a place where stars are born in big columns of gas and dust. The Hubble Deep Field showed us thousands of galaxies in a spot that looked empty. The HST checked out planets around other stars, spotting stuff like water and organic bits on faraway worlds. Maybe some could have life. It also watched the closest seen supernova, SN 1987A, and told us about how big stars live and die. The Hubble Space Telescope is key to today's space thinking, amazing the world with its big finds. Its replacement, the James Webb Space Telescope, was launched to build on those gains, and make an example of our understanding of how the universe started. Today that's what the Big Bang explains. 13.8 billion years back, the universe began as a tiny, hot point. It grew fast, making matter, energy, and forces. As the universe grew, it cooled, making atoms, stars, galaxies, and all the stuff we see now. The Big Bang idea also says why we see background radiation and light parts and the look of the universe today. Even though most people take it as correct, the Big Bang idea had problems at first. Other ideas, like the steady-state theory, said the universe didn't have a start. Some folks doubted the proof for a tiny start, growing universe, and problems they spotted. Over time, most of these problems were fixed. Big proof was when they found background radiation in 1965, which the Big Bang said should be there. Space missions like COBE and WMAP, plus better tech, also backed up the idea. Precise measurements of background radiation match the idea really well. Then comes the James Webb Space Telescope, with its cameras that can peer through space dust. Working mostly in the infrared, the JWST sees the oldest light and watches things form right after the Big Bang. Infrared lets it check out star-making spots and stars' birth hidden from telescopes using normal light. Infrared light has longer waves than normal, letting it get past dust. That's why the Hubble Space Telescope couldn't do it. The JWST can see cooler things that send out infrared, so it's great for checking out planets, brown dwarfs, and faraway galaxies. As space things move away, their light waves get stretched, shifting them the way of longer waves redshift. The JWST spots these signals, capturing light from the early universe and how it grew. Things like black hole crashes or new stars mostly send out infrared, so the JWST can check those things out. The scope can explore things we couldn't see otherwise. With more camera power and infrared vision, it makes optical scopes like Hubble better. All this lets it look farther and deeper into space history, showing off hidden wonders and giving us a better look at how things changed. The JWST is our window into how the universe began. Recently, it found something so weird it could make us rethink the whole Big Bang idea. We found big groups of galaxies at the very edge of what we can see. These old galaxies were there just a few 100 million years after the Big Bang, during the start of the universe. What's weird is, we don't know how such big things could have formed so early. This finding might make us rethink what we know about how galaxies form and grow. Checking our early galaxies can unlock where we come from. The JWST can learn about how galaxies, stars, and planets came up and changed over billions of years. These looks also help with big questions about what the universe is, how it's set up, and what forces control it. While the Hubble Space Telescope was amazing for its time, it couldn't see the early universe well. The main thing was that it couldn't go through space dust or spot the infrared light from old galaxies. Older scopes used normal light and ultraviolet, so they couldn't explore the early universe. This is because dust and gas swallow or mess up those light waves. The James Webb Space Telescope is a big jump in seeing galaxies from the early universe. Unlike the others, the JWST can see space things that formed within a few 100 million years after the Big Bang. With its infrared vision and sharp pictures, the JWST has found a lot of old galaxies, giving us an eye-opening look at how the universe changed. Initial finds from JWST have caused a shake-up in models of the cosmos. The data throws into question many parts of today's theories, so space scientists are rethinking how the cosmos began and formed. Differences between the data and theories have made for big-time debates in the science world. The JWST found more galaxies in the early universe than we thought, meaning it grew way faster than thought. Also, some galaxies look more formed than thought. The finding of huge amounts of galaxies throws into question how big things are set up and arranged, showing a more complex universe web than we thought. These finds raise fun questions and new things to explore. Big objects so early push us to hone models for an easy-to-believe explanation. Figuring out how this stuff grew needs an explanation that doesn't break the cosmos. There also seems to be bigger divides in early conditions compared to predictions. Simple, these twists caused us to step back, rethink, and fine-tune our models. All we can say is that further exploration is required to make these finds part of what we know.